everyone, my project 1 is about the Beijing water cube. The main idea to get this parametric model start from getting the shell, do the Voronoi 3-dimension of the box and the intersection, model the bubble ETFE facade of all the faces with weaver and finally do the parametric modeling of frame thickness by weaver. Through the domain box to create outer box and inner box to get the shell through the solid differences. The parametric inputs include the length, width, height of the outer box and the peripheral top thickness. So if I change the value here, you can see the differences between the model. Second step, I use the Voronoi 3-dimension to create random cells in the outer box and do the solid intersection to create the cells only in the shell. The parametric inputs are the number of the cells and the random seeds. Here's the model of the Voronoi 3-dimension with shell. The third step is about modeling the bubble ETFE facade of outer surface by weaver. First, to select the outer surface, an imaginary box which is a little bit smaller from outer box has been created. Then the point in the graph is used to find outer surface of the cell. To create the bubble shape, the central point of each outer surface cell would be extruded outside of the box. And to smooth the ETFE facade, I use the weaver component to realize it. To the parametric input here is the extrusion height proportional to the area of the cell facade. If I change the maximum height, you can see the differences of the model. So there were two problems during the modeling process. The first is about after the solid intersection to get the Voronoi 3D shell, some central points of faces cannot be extruded outside the box because the normal vector direction is opposite. What I want to do is to find the point in graph to find the Boolean list of each normal vector point of the box, and then use the member index and Python code to find the index of these vectors and do lective to get the right direction of normal vectors. This method can be also done by the list method here. The second problem is that I just set the constant extrusion height for every cell faces. But when it comes to the small area of the cell faces, it is not good to see that. So I use the remap numbers, this component, to get the extrusion height proportional to the area of the cell facade, which is more sensible. So last step, I use weaver mesh thicken to simulate the frames. So the parametric inputs here are the width and the thickness of the frame. If I change the value here, you can see the differences of the model. So finally, after baking, so you got the complete model with it.